Welcome back, smart mathematicians. Let's do question 11.2.2. In the diagram, PK is the tangent to the circle at K. Chord LS is produced. This is chord LS is produced to P. N and M are points on KP and SP respectively, such that MN is parallel to SK. Chord KS and LN intersect at T. Prove giving reasons that triangle LKN, this is triangle LKN, is similar to triangle KSM. So we want to prove that triangle LKN is similar to triangle KSM. So how can we prove that the two triangles are similar? It's either the corresponding angles are equal or the corresponding sides are in proportion. So here we have to use the angles because we are not given any sides, isn't it? Let's discuss this. So we have triangle LKN. So let's say in triangle LKN and triangle KSM. This must guide you. It means angle L must be equal to angle K. Right? Angle K must be equal to angle S, and then angle N must be equal to angle M. So you can even write it. Let's just say, let's start with triangle LKM. So it's L goes with K, and then K goes with S, and then N goes with M. See that? Okay. So we have to prove that angle L, like in this case, angle L1 is equal to angle K2. And then we have to prove that angle NKL is equal to angle KSM. And then we have to prove that angle N, which is N3, is equal to angle M3. Let's start with angle N3 and M3. I think these are the easiest ones. Remember, we proved that quadrilateral KLMN is a cyclic quad. Okay, so now we can say angle N3 is equal to angle M3. Why? Angle N3, let's start with the angle N. So N3 is equal to angle M3. Why? These are angles in the same segment. If you check, they are subtended by the chord KL or the arc KL, both of them. So they are angles in the same segment. Okay. All right. So we have what? One pair of corresponding sides. We just need two, and then the third pair just becomes automatically equal. And then let's go to the second one. All right. The second one, what can we say? We have angle L1. If you check, we have angle L1. Angle L1 is equal to angle M2. They are subtended by NK. They are subtended by NK if you check. But if you check again, this angle M2 is equal to angle K2. Do you agree? Angle L1 is equal to angle M2. And then angle M2 is equal to angle K2. You see that? Angle L1 and M2 are angles in the same segment, and then angle M2 and K2 are alternate angles because NM is parallel to KS. See that? Okay, let's just write that. So we have angle L1 is equal to angle M2, right? Angles in the same segment. So these two angles are equal. And then again, angle M2, but angle M2 is equal to angle K2, since they are alternate angles. MN is parallel to KS. Right, so these two angles are equal. So we can say, therefore, since angle L1 is equal to angle M2, which is equal to angle K2, so it means that angle L1 and angle K2 are equal. Therefore, angle L1 is equal to angle K2. Okay, right. So now, therefore, the third pair, it meaning that angle NKL, we don't even need to write that, this two are fine. So angle NKL is equal to angle S2. This is the third pair of triangle. Okay, so it means they're equal. So now they can then conclude and say, therefore, triangle LKN is similar to triangle, right? L goes with K. You can see here, L goes with K. This is L, so the first one will be K here. And then L, K, or K, this angle goes with this angle. So it's K goes with S. And then we have the last pair, N goes with M. You can see here, N goes with M. Okay, so we've proved that triangle LKN is similar to triangle KSM. And then the reason, don't forget, angle. Let's go to the second alternative method. Prove giving reasons that a triangle LKN is similar to triangle KSM. So in triangle LKN and triangle KSM, so we have this triangle LKN and triangle KSM. So we've discussed this in the previous method, so let's just move fast here. So we agreed that angle N3 is equal to angle M3, isn't it? Right, so we said angle N3 is equal to angle M3. Angles in the same segment. And then now, remember this is a cyclic quad, KLMN is a cyclic quad. So we have angle NKL and angle M1. Okay, they are equal because angle M1 is an exterior angle of a cyclic quad. Okay, but if you check, angle M1 is equal to angle S2 because these are corresponding angles. MN is parallel to SK. You see that? And then meaning that angle NKL is equal to angle S2. So let's just write that. We're saying we have angle NKL. Angle NKL is equal to angle, first of all, we say it's angle M1. Angle M1 resin exterior angle of cyclic quad. But angle M1 is equal to angle S2. Since we have, these are corresponding angles. MN is parallel to SK. Right, so these two angles are equal. So therefore, since we have angle NKL is equal to angle M1, which is equal to angle S2, therefore angle NKL is equal to angle S2. Therefore, angle NKL is equal to angle S2. Okay, right, so these are the two pairs that we have. So the third pair becomes which angles? This angle and this angle. See that becomes the third pair. So now we can say, therefore, triangle LKN is similar to triangle angle L. This angle goes with this angle K there, so it's K. This L goes with K. And then K meaning NKL goes with this one. For the first K, there was K2. Please don't make a mistake with that. It was K2, but now this K, we're talking about the whole K, NKL. It goes with angle S, then, and then angle N. This one is easy. Angle N goes with angle M. Triangle LKN is similar to triangle KSM. Was angle, angle, angle. Okay, right. We have proved that these two triangles are similar. We're going to meet when we do the next question.